Hi, I'm Szot, the VP of Innovation and Solutions at Esper, and today we're going to talk about AOSP versus GMS and the considerations for you as you build out your dedicated device fleet and trying to figure out which of these Android variants you're going to use moving forward. Hi, I'm Szot, VP of Innovation and Solutions at Esper, and you're watching Fleet Geek. Build your dedicated device fleet your way. So let's start out at the top level of what is AOSP and what is GMS. So with AOSP, that is the Android open source project built and maintained by Google and made available for literally anyone to be able to take the Android operating system and modify it if you wish. You can actually fork it, which the Fire OS with Fire tablets would be one example that Amazon does. Or you can build off of it and create your own devices of really any kind, any shape, any form. And so to give you an example of that, at the extreme, this is the Szot SD7, one of our partners, and this is an Android-based device, but it has no display. It literally looks like a telephony communication device, but it's running the Android operating system. And by the way, managed by Esper. They're one of our partners that we work with very closely in the first responder space. So you have a lot of diversity of what you could do with Android open source. And from that, Google maintains it with security patches that they post, so that to the degree that whoever is building the OS wants to maintain pace with covering security issues and vulnerabilities that are found by Google and the community, they're free to do so through AOSP, but they are not required. So this is great if you want a lot of control and ability to create whatever type of device you want. Now this abuts GMS. And so essentially think of GMS as something that is built on top of AOSP by Google. It stands for Google Mobile Services, and this is where Google focuses on delivering a set of capabilities that are intended for both the consumer and the enterprise markets. So the obvious one are the apps. With GMS, you get YouTube, you get Chrome, etc., etc. And so this is the base set of Google experiences that they want to deliver to both the consumer and the enterprise markets. Furthermore, you get Play Store. And Play Store has an amazing set of ISV apps that are available for both consumer and businesses to be able to use. But the only way that you can get it and be part of that Play Store ecosystem is through GMS. There's a little bit of an exception over here that I'll mention later on. But generally speaking, you're only going to see it, or you're only supposed to see it on GMS-based devices. The other part of this are developer services, if you will. So there are a set of capabilities that are very appealing to developers, with Firebase being a leading example. So they ship Firebase with GMS, and from that you can effectively communicate with your app, and you can track app crashes and the stability of your app using Firebase. So GMS is a very nice package that offers a lot of value for both the ecosystem as well as consumers, but there's not a free lunch around this. So in order to do this, since it's targeting consumer and primarily enterprise use cases, you're going to have constraints. And these constraints are rules around device requirements. So this is the set of capabilities that the device must deliver. So things like you have to include location services in it. You have to have particular aspects of the user interaction design of the device. And in order to be able to be licensed for GMS, you have to meet those particular certifications. There's actually a series of tests and validations that Google does that they pre-publish. So that way you know exactly what you need to target and what you're getting into as a device maker. And then you basically work with Google to be able to achieve certification and be able to ship that device. And when you do that, you get beautiful devices like this Samsung flip phone, right? So this does indicate that Google does progress it, and so this is a different type of design, and so things like Android 12L, as an example, that will be coming out in tablets through GMS, is the direction that Google goes, but they essentially control it. It's different over on the AOSP side, where you're free to do whatever you want and need to be able to create your device. Now, the trade-off here can come from, well, how do you maintain this? I mentioned that Google puts security patches up to AOSP. These are then made available through to GMS, and the device maker over here is responsible against a set of rules or guidelines that Google attempts to enforce about how those GMS devices are kept up to date. This is very important for Google because for their flagship products that they're driving with the ecosystem, they want to make sure that these devices are not sitting out there with security holes, but they need to counterbalance it against a fast-moving consumer market where the lifespan of the devices typically is just a few years. So that's a very, very important design consideration because you see a lot of churn of models over on the GMS side as they chase the consumer market. And so if you have a model that has been introduced in 2022, don't expect it necessarily to be around in 2024. And also the amount of time that the operating system is maintained is variable depending on the business model, the behavior of the OEM, the device maker. And so that also tends to be non-uniform. The great example is the Pixel. So Google controls the updates to the Pixel, and they are the flagship for how they maintain the operating system. But there are other OEMs that are out there that don't update the operating system very often at all. So that's a very important consideration. And on the other side, on AOSP, you're basically on your own. So with that, it is up to whoever created the device to do the work to build these security patches that Google creates and post to AOSP to then deliver it in a form that you can install on the device out in the field. So that's a lot of work. It can work over here because the requirements and the economies of scale and the economics associated with all these devices in the consumer market. This can be a much tougher one because this does not include the infrastructure to effectively do the updates. And so this is like the cloud service to be able to do it, to push it, to actually do the work to build this. It costs money. And so for some companies, it just doesn't necessarily make sense to do it in the AOSP world. But the beauty of it is really driven by the business case. And so in some situations where it is very important for the end use case to be able to do that, you do have the ability to deliver it if you do it in a coordinated fashion with the company that's building the device. Now, interestingly enough, this tends to include silicon vendors because they typically create the reference design with the initial Android OS build, many times on AOSP, and they set it up to be able to be built on top of, or GMS built on top of it. But this goes to that the device ecosystem is very interconnected and the silicon vendors are a very important part of it. So that's the basic draw of AOSP versus GMS to give you a flavor of that. Let's move on to the next part of what does this all mean for you? All right, let's get into this wild and woolly world of like, how do you figure this out? Well, the first consideration that I think is a very important one is the power of Android is the developer ecosystem. And so there are literally millions of developers. It's the biggest developer base in the world today. And so you want to bring that power of the application set and the development community over to your world. But the thing is that GMS app devs, as I call them, are dominant. And what that means is that they understand the API set that Google puts out there to build apps for GMS, and it also means that these ISV apps may have dependencies to GMS that it requires a GMS-based operating system in order for the apps to operate. So that means that you cannot just pluck an app that is built for GMS and run it on an AOSP device. Because as we talked about, AOSP, while it's the base for GMS, is essentially a subset of developer capabilities that you have available on GMS. The other aspect of it is these ISVs are targeting Play Store. And so when these apps target Play Store, they're not intended, even if they could, to run on an AOSP device. They're intended for GMS devices. So what you see here are these mirror sites that will take these apps and then make them available for you to be able to put on any type of device you want. the first step is, does it have GMS dependencies? Will it operate on the AOSP device? But beyond that, do you have the licensing to be able to do this? Because that app was intended for Play Store. So you need to be careful with mirror sites. Licensing certainly is one part, but you don't know the integrity of those apps necessarily when they're not directly from Play Store. And so this is where the concept of Managed Google Play comes in, by the way. So Managed Google Play is a special aspect of Play Store that is intended for managed devices. And Esper offers this so that if you have an Esper account, an Esper cloud instance, you can create a managed Google Play Store instance within that. So that way you can control which Google Play apps that you can make available to your fleet and be able to install them. So that's very convenient, but there is a trade-off, is that Managed Google Play, the whole Managed Google Play infrastructure is literally designed for billions of devices. So the deterministic behavior that you may want to see for dedicated devices, you're not going to be able to achieve that through Google Play. So it's a total trade-off there, that you can get all sorts of apps quite easily and made available through Managed Google Play, but you may not have the type of DevOps for devices behavior that you're seeking to effectively control your fleet. So you jump over to AOSP, and then it becomes, well, how do you get your apps? So a lot of times you see, just like you might see custom-built devices, you see custom-built apps. And we actually make this pretty smooth for you. We do things like provide you an emulator that targets AOSP that you can drop into Android Studio. We tie it in with our Android Studio plugin so that you can quite easily upload an APK build, trigger a pipeline so that you can roll it out to your test lab. So we try to accommodate this use case very well, but it does mean that you're not going to be able to take those GMS APIs into AOSP. Now, the one thing that we do see at the operating system is occasionally these AOSP devices support Google Play. They're not supposed to. They do come out and we do see them, but technically these AOSP devices are not supposed to have anything to do with the Play Store. So what we have done in the past is we do have customers, and this is a key point, is that through Esper, you're not committed to either GMS or AOSP. Our platform supports both, and in fact, we're a big advocate of mixed fleets. Because the reality is when you look at GMS, you have the diversity of devices that are available for you to obtain to build your fleet off of. They're off the shelf, they're usually very economical, driven by the economies of scale. So for certain aspects or certain subset of use cases, these types of devices are very good to apply. But that doesn't mean that you're limited just to GMS devices, where you can also have a mix for particular use cases, that you can have AOSP-based devices be part of your fleet. And through Esper, you can control and mix and match which applications you target for these devices. And across them, by the way, we have this thing called the Esper App Cloud that works across GMS and AOSP devices, so that if you have access to the app yourself, if you've built it yourself, if you're working with the ISV, you have very fine-grained deterministic control of how you install, update, track the status of those apps across your GMS and AOSP devices. So to bring it back around, what we do is, if you have a particular GMS app that you have, and we've done this with several ISVs, we work with them to identify the GMS dependencies, discuss the trade-offs of removing them, and help them build a version of their app that will work on AOSP to benefit the end customer. So very experienced at that, and something that we can work with ISVs or your internal app developers around. So that's a big part, is the app view of what you're getting into of GMS versus AOSP. So next we're going to go into hardware design around AOSP versus GMS. So as earlier discussed, with AOSP, you have the freedom to build whatever you want. No display, like I showed you with the SD7, basically using variant UIs, UXs. You can put whatever kind of buttons you want on it, whatever kind of screen that you want on it. You're not constricted in any way, shape, or form. So we think that this is a very important direction, because what we're starting to see is that collision and crossover between IoT and smart displays, where AOSP is a fantastic operating system in the IoT world. We see it in autonomous vehicle type designs. We see it in variant types of tablets that have very specialized use cases, and where the customer wants full control over not only the experience, but the software and the hardware of the device itself. So if you need to have a very particular design that doesn't fit into the rules of GMS, this is the way to go. However, if from a hardware perspective, your use case can be satisfied by one of the standard tablets, one of the standard smartphones, then GMS is a great way to go. You can buy it off the shelf, you can utilize it, you can get it in volume at a great price point, and you're good to go. One difference though is how long do you need to be able to purchase this device? If you commission device with AOSP, it's between you and your relationship with the ODM, the supplier. And that can go on for years, depending on what kind of business deal that you strike with them. On the GMS side, you're beholden to the pace that the consumer and enterprise markets are driven by around innovation with tablets and smartphones. So you're typically going to see a 1 to 2 year window of availability before you're going to have to switch out. Now, for some use cases, that's okay, but we've encountered some, like in the clinical trial space, as an example, where it's very stringent and you need to lock in on literally a particular model of a device and hold it with the operating system version built on it for years. You're not going to be able to do that very effectively over here because the device makers have already moved on 2 or 3 models beyond that. And so in that particular situation, an AOSP-based device probably is a better fit for you, or a specialized vendor that is able to pull it off in GMS, which there are very, very few. I will say that GMS is evolving a bit, where Google recognizes that some vertical market use cases are important for what they're trying to do. So I think that you're going to see this evolve over time, but kind of the state of the market is if you need longevity, availability of hardware, and control over the OS, you go AOSP. GMS is to take advantage of the economies of scale of the consumer and enterprise markets. Now that takes us into OS updates as the next topic. So on the OS side, when you're over in GMS, like I said, you are dependent on the device maker for delivering OS updates to the device. So part of this is you don't have full control. There are some knobs for OS updates, but generally speaking, what Google is trying to do is work with the device maker and in some cases the mobile operator, the carrier, to ensure the robustness across these billions of Android-based consumer devices so that security holes are covered with patches. And so that means Google has set up the rules to try to push those things out, which is not always what you want. And so if you're willing to give up that fine-grained control of how operating system updates are passed to the devices, GMS is not a bad choice. There are some proprietary extensions that vendors offer. We support them for Lenovo, for Samsung, for Bluebird, that allow you to stop firmware updates to devices. But that's the exception. It's not the standard package, and you have kind of defined windows that Google supports through the OS to be able to control those updates. So you have to be willing to accept that the composition of the operating system will change. You're not always going to be notified because the OEM is going to push out that update when they're going to push out that update. We've had surprises with compatibility issues with dedicated use cases and the purpose-built app that runs on them that they break when a firmware update is pushed out. So you have to be willing to accept this and have a method around it to have some canaries out there with a fast reaction team ready to go if it's very important for you to maintain your app compatibility. Generally, it's not a problem, but it does happen. On the AOSP side, it's nice, but challenging. What this means is that, well, you're kind of responsible for ensuring that you get those updates built. You have an update engine built into the OS that you're shipping it with. You have somebody providing the service to be able to build and push out those updates. So you're very much on your own on this side. And by the way, Esper can help a lot here, and that gives you full control. So this is nice that if you want to freeze on a particular OS release with no changes, you want to set the pace and completely control how those OS updates are rolled out to your fleet, you can do whatever you want. But you own it. And it's your responsibility to be able to maintain it. So a very big trade-off between the two. It really depends on what you're trying to do and what your economics and your supplier relationship is around the operating system and the updates. The last but important consideration, I call it money, but it really is vendor and supplier relationships. When you go over to the GMS side, it's relatively clean because you're dealing primarily with OEMs. You're buying kind of a standard offering. And so you know what you're getting into. It's already built. You can negotiate the price point as you go into volume. But this is a much more standardized offering also too with service and support. There are not a lot of unknowns around this. You can get track records of device makers. You know how they behave. You know what you're getting into and what to expect. And you generally know how much money it'll cost going in. On the AOSP side, well, typically you're talking about custom-built devices here. There are some AOSP devices available from vendors such as Honeywell, Zebra, etc. And so they do have a mix of their fleet AOSP, but generally to get this done, you're dealing with ODMs out of Asia. And for that, you're going to have to negotiate with that ODM the design that you're trying to build, because typically they're going to have a base design that they offer, and some of our customers just take the base design as is and go. Other times they're going to do a back and forth with the ODM to make modifications to the hardware design and also the OS potentially to be able to achieve the use case that they're targeting, or it's literally commissioned from scratch. And so that's kind of the extreme where you start with a reference design from a silicon vendor. Sometimes our customers do the design themselves in the United States, and then essentially they put it out to Asia to be able to get it to manufactured, to get it to be able to be manufactured. So there's a lot of different ways that this can go, which means a ton of complexity, also more risk because you're essentially owning the product, right? And you're doing a deal with an Asia-based supplier that you better understand what the terms are. And by the way, get those terms, whatever you want in that original contract, because once you sign, you're going to be held to that in your relationship with the supplier. So this is where things like we were talking about, firmware updates, OS updates. What do you want there? Do you want an OTA engine built into it? Do you want them to be building updates to the OS? Do you want to be able to do those updates yourself? Do you want to be able to modify the OS yourself? That means that you're going to ask them for source code for their OS image. And so if you do that after you sign the contract, it's really, really tough. But if you do it when you're negotiating around the hardware, because the ODMs really are about making the money off the hardware devices that they sell, then you're much better off. And then service and support. How are you going to handle breakage, break fix? Where is the tech bench going to be? So many more considerations here that typically this is driven by a more sophisticated entity commissioning these types of devices, or such a specialized use case that you're going to need to go AOSP with ODMs in order to accomplish it. So the way that I look at it is, hey, over on this side, if you're just getting into dedicated and your use case is pretty crisp and clear, GMS-based devices are not a bad way to go. Especially if you want to take advantage of aspects of the GMS technology stack that Google offers. It's a wonderful thing what they provide through GMS, a lot of capabilities and services that frankly are free that they include through GMS. But on the AOSP side, well, you have that full control, and if you know what you want to build very precisely, you can go ahead via the AOSP route. That said, you can mix and match. Goes back to if you have use cases that are just solid for Android-based tablets that are using GMS, go for it. There's a lot of options out there, a lot of offerings. But if an aspect of your fleet, let's say that you have a human-machine interface that's an Android tablet, but you have this quasi-IoT to smart device that you need for telemetry that goes into your scenario, it makes sense to build that on AOSP, get that tablet on GMS, and have the best of both worlds. So to wrap it up, we're talking about AOSP versus GMS. Rich platform over here, apps, services, developer technology, all packaged and ready to go. Very, very nice. Great set of devices available to you around common form factors. Very easy to procure. I would call this known. Drawbacks, well, you have to sit in the box, and if you're building devices yourself, you have to go through the process to certify and maintain that have rules set by Google. May not work for you, may work just fine. On the AOSP side, freedom. You can build whatever you want. And Google very nicely provides this huge code base for you to work off of, which is like unheard of, fantastic, but you also have complexity. And with complexity comes risk. There's a lot more things that you have to deal with here, but it really depends on what you're trying to do with your use case, where if you need full control, you need to have long-term availability of the hardware. AOSP could be a much better way for you to go with this. Now, it's important to note that we completely understand this, and that's why we have our operating system that essentially is what I call GMS for dedicated devices, which is Esper Foundations for Android. So similar to GMS, what we do is we build additional services and capabilities created specifically for dedicated devices on top of AOSP. We're not a fork, we are AOSP, so we stay in compliance, if you will, with what AOSP is, and we give you a lot of great new features. So this is a great opportunity to just mention Esper Foundations for Android. So think of it as like what Google does with GMS, which is really smart, right? They basically build on top of AOSP and give you a bunch of capabilities for the consumer and enterprise markets. With Esper Foundations for Android, we're doing the same thing, basing off of AOSP and building these capabilities for dedicated devices. So we'll cover that in an upcoming video, do a deep dive on that. But generally speaking, if you're facing these questions of trying to figure this out as you design your fleet, as you spec your fleet, please come to us. We're device geeks. We love Android. We love use cases. We love working with prospects and customers to basically figure out these cool new ways that you can use the Android OS, the bountiful hardware ecosystem around Android to create cool solutions, cool use cases, cool devices. So with that, I hope you enjoyed this video. Please talk to us. We'd love to connect. Thank you.